Hello, and welcome to this ANSYS Space Claim tutorial on tips and tricks using the Merge and Subtract tool in the Facets tab. We'll be taking a look at how we can use the Convert and Separate tool along with Merge and Subtract to do some more advanced workflows. If you haven't already, go to File, Open, and open up Plastic Molded Tips found in the directory where you downloaded the file. If you've just started Space Claim, you'll be in the Design tab, but you want to go over to the Facets tab, which is an additional add-on. In the Basics section, we took a look at how to use the Merge and Subtract tool in order to merge solids or meshes into other mesh bodies. One thing you may not be aware of is that in order to merge a solid body into a mesh body, it needs to be converted into a mesh body first, but this is done in the background automatically for you. At some point, you may want to control the resolution that the solid is converted to for a number of reasons. But let's take a look at how to do this. The resolution for which the solid is converted to a mesh is controlled by the Convert tool. Notice the options on the left give you a maximum distance and a maximum angle. And you might be wondering, what exactly does this mean? So if we hover over the Convert tool and press F1 for more help, like it says at the bottom, we can get an explanation of the settings for converting to a mesh. If we take a look at max distance, you could see here on the left, we have a larger max distance than on the right. This max distance represents how far the faceted face can be from the original curved face. With a larger value, you get a greater distance. With a smaller value, you could see a much smaller distance between the faceted faces and the curved body, and this usually results in more facets. You can see a bunch of edges here, representing 5 or 6 facets, and here there's only 1 or 2 edges. You can also see here down around the bottom or the top that there's a few medium-sized triangles, while here those triangles have been split into more smaller triangles. The maximum angle is very similar. Here you can see with 2 of the same maximum distances. With a larger maximum angle, the triangles are bigger than with a smaller maximum angle. So in a gist, lower values result in a more fine resolution and more triangles, and higher values result in less triangles and more coarse faceted meshes. Let's go ahead and take a look and see the big visual difference here. I'm going to turn these up quite a bit. I'm going to make the maximum distance 2 millimeters with a maximum angle of 20. Now I'm going to go back to my merge tool. I'm going to select the mesh that I want to merge into, and then the solid I want to merge to it. If we zoom in here, it looks pretty faceted around the top. I'm going to escape out of the merge tool here, and we can see these straight edges on the top, and of course it still has to connect to the smaller triangles on the bottom. Let's move over to this one here, go back into our Convert tool. I'm going to change this to something rather small, 0.1 and 1 degree. We'll go back into the merge tool, select the body to merge into, and the body we're going to merge. Notice it takes a little longer to compute, and here we can see many more triangles. And to drive this point home, if I escape out of the merge tool and double click on the top here, we could see 358 facets compared to over here, where if I double click on the top, we only have 16 facets. So higher values will give you a finer resolution, but it'll often take more time to compute. And if at any time merge or subtract doesn't work with a solid and a mesh, try changing the convert parameters or options to be a little more coarse and less fine, so higher values. For the next tip, I'm going to go ahead and zoom out and show the hidden solid in the tree, the fixture. And here we've already created a solid block. It's not a mesh, it's a regular solid. We could see it has a couple different steps on it, and that's to be able to properly support the different steps on our workpiece. Here we can see some different steps on the back, and we always want to make sure that the fixture does not go over any of the faces on the top here. So you could see we have this step here for this face, and then based on the step between the handle and the main part of the body right here, we have an additional step on our fixture. Now, if we want to cut the fixture with our workpiece, you might try to do a subtract operation, but you're not able to select a regular solid to subtract from. And if you've used Space Claim for regular modeling, you might try to use the combine tool to do the Boolean operation. And the main solid body can be our target, but the faceted mesh cannot be our cutter. So what we're going to do is, you'll remember, we can subtract a mesh from a mesh. So we're going to use that convert tool we were using a second ago. And right now the parameters don't really make a difference. These only apply when you're converting a solid that has curved geometry. When it's all planar faces, this really doesn't make any difference. So we'll go ahead and convert this. We could see there are a number of large triangles here, but that's just because we only have planar faces on the model. But now that we actually have a mesh instead of a solid, we could use the subtract tool, select the target body and the cutter, and it'll go ahead and subtract it out. Now I've gone ahead and left the keep cutter option on just so we don't lose our workpiece. And I'm going to escape out of the subtract tool and hide the design mesh in the tree. Now you can see here that it does appear that cutouts were made, but we still have that inner solid that we don't want there. And one big difference when we do a subtraction or a Boolean on a mesh compared to a regular solid is that the mesh does not automatically separate into different bodies, even if they're not connected. So for that, we want to use our separate tool. And if I turn this on, notice I can hover over the main fixture that we want, or this extra piece that I don't want. And in this case, it doesn't really matter which one that I separate. I'm just going to click one here, and we'll see that we now have two distinct bodies in the tree. We'll escape out of the separate tool. And I'm going to right click on this extra inner piece that I don't want, and I can delete it, or I could hide it by unchecking. Now here, it's a little hard to see that there's a pocket down in there, and that has to do with the fact that we're displaying all the different edges on these faceted faces. But one thing you can do is go to the Display tab, and over here there's an Edge Display menu, and under Mesh you can turn off Internal. Now you'll see less of those edges on the inside, and when you spin the model around, you can get a much better feel for what the actual geometry is like, and you can actually see the cutout of our workpiece in this block, and this can be sent off to be machined or even 3D printed if you're trying to create some sort of assembly fixture, even a mold, or this process can be used for creating mated parts. Thanks for watching, and have a great day.